We've got an illusion here. I'm going to actually present it so as anybody watching this video can try it out for themselves. But basically, as it says at the bottom, you can stare at the dot on her nose, stare at her nose for 20 seconds, or 20 to 35 seconds. And then after that, stare at this blue dot over here. So pause the video, give that a go. And what you should find out is that you get a kind of normal image of the girl on this right hand side, just kind of appearing in your mind's eye. So how does this work? Well, basically what's happening, and I'll just come out of this now, out of presentation mode, so we can have a look at how our eyes work. We have at the back of our eyes a retina, and this retina is made out of light recepting cells called cones and rods. Now, our cones and rods, our rods detect just any old light, and our cones detect specific, more particular to specific wavelengths of light, blue, green, and red cones, we call them. And the colours in between, we see those by both cones, two cones near to that wavelength, reacting and feeding our brain information that says it's somewhere between these. Anyway, that's how we see the three different cones. Now, so what would happen? So what is this image that we're seeing in this? What's this image we see of her? Well, that is a negative of the actual image that we're seeing. So to explain what a negative image is, I think I need to get another little diagram. So I'll just get that now. So this is a color, like a Venn diagram of colors, basically, but you can obviously make it by shining red light and blue light and green light. Where the red, blue, and green mix, they make white light. So white light is nothing more than just a mixture of all the different colors. And if we just mix red and blue, we get magenta, blue and green makes cyan, and red and green makes yellow. So it works in a different way to mixing paint colors or crayons or felt tips. And so that's how. Oops. What's going on? Oh, okay. I don't know what just happened there, but it looks like I'm still recording. Okay. My screen just did something. My computer just did something really weird and just opened up something randomly. Anyway, so basically, yeah, this is like all the different colors. And so what is the negative then? We've got a negative of that woman up there. Hang on a second. Okay, so a negative is whenever we want to see magenta, the negative of that would be green. Whenever we see yellow, the negative of that would be blue. Negative of red would be cyan, and vice versa. The negative cyan would be red, negative of green would be magenta, and the negative of blue would be yellow. So what's happening is that at the back of our eyes, if we're just looking at a yellow square. In fact, this can be demonstrated quite well with just a yellow square right now. If I can, let's just get a yellow square and we can demonstrate it. So we'll just draw a square and color it in with yellow. Okay, and if you stare at that yellow square, we can pause the video again and stare at the yellow square for, say, 20, 35 seconds. You will find, let's say, I'll copy that square actually and just put it just below. And this time I'll put a white circle, a white one there, make that white. So you stare at that one for 20 or 35 seconds, then stare at that one, you'll see the negative of that, which will be blue. So this square will be blue. So the reason why that's happening is because because yellow light is a mixture of red and green, that the red and green cones at the back of your eye are getting very, very tired, whereas the blue ones are getting a rest. So when you see white light, then the red and green ones don't fire so strongly, but the blue ones do. And so you end up seeing the remaining color. So the other two of the three light cones have gone sort of sleepy and have become deactivated. to kind of protect your eye, essentially protect those cells. Whereas the one remaining is still working quite well. It's still full of energy, and so when you shine all the different colours, it's only the blue one that is actually the one that is able to detect the colour. And so and the same would happen with all the other colours. So essentially, we're all around here. You're different. It's basically painting this picture at the back of your retina, and this is actually a good point. That when you're looking at anything, essentially we look at something and it looks like it's out there, like in front of me, and that illusion essentially can be emphasized by the fact you can see your finger pointing at it. But everything that you see is a representation of what's out there. It's actually all painted at the back of your retina. Everything that you see is actually in your eye. But it's a representation of what's out there, which is why illusions work and so on, because we're trying to second guess what's out there. So, and all these illusions are based. The reason why they're at all surprising is because we assume that we have an accurate image of what's out there, but it's not accurate, and these illusions routinely show that we don't see things as well as we think we do. So I think I've kind of rambled a little bit about there, but I think I pretty much explained how that works. So I'll stop the video there.